Hello everyone, I am Dr. Pallavi Ram. Welcome to my channel Probabilistic Revelations for Engineering. In this video, we are going to see some problems on combinatorics and probability. So the first problem that we are going to take up is, let us say there is a box and the box has several balls which are numbered. So say 1, 2, 3, 4 and 5. So there are numbered balls, and from this we draw out two balls in succession. So two balls are drawn out in succession. So one after the other. And we need to find the probability that the largest number drawn out is equal to the number 4. So the largest number that is drawn out among these two balls is always the 4. So this probability, what is it? We are going to find out. So first let us see this problem. So there are two balls which are drawn out in succession. So how many possibilities are there? How many combinations will be there to draw two balls? Let us see. So we can draw out 1, 2, 1, 3, 1, 4, 1, 5. Or we can draw 2, 3, 2, 4 and 2, 5. 3, 4, 3, 5 and the last 4, 5. So these are the combinations that are possible. So you can check them with 1, all the others combinations, with 2, all these combinations, with 3 and with 4. So if with 4, with 3, if we go back and write for 3, 2, 3, 2 is again 2, 3 itself. So when two balls are drawn out in succession, if first 2 is drawn, second 3 only can be drawn. If first 2 is drawn, then 3 can be drawn next. But in any case, we will get 2, 3 as only one particular possibility. That is why we should write only the combinations but not the permutations. So totally, if you observe 4, 5, 6, 7, 8, 9, 10. So totally 10 possibilities are there. Now out of these 10 combinations, what is the largest number that should come always? That is 4. So 1, 4 is one option that we are looking for. 2, 4 is one more and 3, 4. 4, 5, since the largest number is not 4, largest number becomes 5, this is not a valid option. So totally, we have 3 combinations where the largest number becomes 4. So that means the probability of this will be 3 by 10. Now let us repeat this problem. So let us take one more example. So this time, let us say the box again has the same 1, 2, 3, 4 and 5. But there are 3 balls drawn out in succession. So in this case, again, we are going to find out the probability that the largest number is 4. So probability that the largest number drawn out is equal to 4. So again, we will try to find out this probability. So now there are 3 balls drawn out. So let us say 1, 2, 3, 1, 2, 4, 1, 2, 5, then 1, 3, 4, 1, 3, 5 and 1, 4, 5. So if you observe, I have fixed this one and assuming that only 2, 3, 4, 5 are there, I wrote all the combinations pertaining to that. Now second, let us now fix 2. So when we fix 2, observe 3, 4, 5. So we can have 2, 3, 4, then 2, 3, 5, then 2, 4, 5. Again, go with 3, 4, 5. So fix the 3. Then we will have only one possibility. So 3, 4, 5. So observe 3 plus 3, 6 total here. Again 3 here and 1 here. So So totally again, there are 10 possibilities. So 10 combinations, let me say. So total, there are 10 combinations possible. Now out of this, we should pick the largest number drawn out should be 4. So here, there is one option. Again here. And in this option, there is 4, but still 5 is the maximum. So we cannot take this case. Then 2, 3, 4, one option. This case ruled out because there is a 5. And even this case, there is a 5. So it is ruled out. So we have the total possibilities where 4 exists. That is 3. And the total combinations are 10. So the answer is again 3 by 10. So this is how we can write the probability when combinatorics is involved. But however, let us repeat this problem again. And this time, let us generalize. So let us say there are balls 1, 2, 3 and so on till n. And let us draw k balls in succession. So k balls in succession. And we need to find probability that largest number drawn is equal to m. So you observe that number of balls are n and we draw out k balls and largest number of that number that is drawn in the largest number that is drawn among these k balls, that is m. So this is like a generalization of what we have done in the previous two problems. So let us generalize. So now you observe that k balls are drawn. So let me write 1, 2 and so on. Let us say the last one is k. So let me write this as capital K. So there are k balls which are drawn. So k balls, now out of these all k balls, these n balls can occupy any of these positions. So that means we choose we choose k out of n balls. So this implies the number of combinations are nck. So if we go back, so here we should select 2 balls and we have 5. So selecting 2 out of 5 means 5C2. So if you calculate what is 5C2, you will see that this is nothing but 10. So total 10 combinations means it is 5C2, which is 5 factorial by 2 factorial into 5 minus 2, that is 3 factorial. So you can calculate this and check, this will be 10. So same way here also. We have 5 balls and we should draw out 3 balls. So these 3 balls can be drawn out and these 5 balls have the option of coming in these 3. So that means out of 5, we have to select 3. So it is 5C3. So 5C3, again you can check this, that it is 10. So same way, when we are generalizing, we have to choose k out of n. That is why the combinations are nck. So these are the total combinations. Now coming to largest number being m. So out of these k again, the largest number among them is m. So that means m should be always there, either in first position or second or wherever, but m should always be there. So there are left out are only k minus 1 options. So these k minus 1 can be chosen from again only the 1 to m minus 1 balls because m is already occupied. So choose k minus 1 balls out of 1, 2 and so on till m minus 1 balls because mth ball is occupied. And if greater than m anything comes, that means that largest number is more than m, which is not the criteria that we are looking for. So choose k minus 1 balls out of these m minus 1 balls. So these combinations are going to be m minus 1, C, k minus 1. So now if we go back, you can see here the largest number we have to draw out is 4. So m minus 1, you can observe the formula here. This is m minus 1c k minus 1. So here m is 4. So 4 minus 1 is 3. C, k minus 1. So we have k as 3 here. K balls drawn out. So 3 balls drawn out. So 3 minus 1 is 2. So 3c2. So if you observe 3 factorial by 2 factorial into 1 factorial, you will see that this is 3. So this 3 is our numerator and this 10 happens to be our denominator. Same way if we go back here. So out of the 2, again m minus 1 c k minus 1. So here 2 is k and m stands for 4. So m minus 1 is 3, c, k minus 1 is 1. So 3c1. So this is again 3 factorial by 1 factorial into 2 factorial, which gives again 3. So 3 in the numerator and 10 in the denominator. So this is the generalized version of the answer. So hence the probability that we are looking for is none other than m minus 1 c k minus 1 divided by n c k. Thank you very much. If you like this video, please don't forget to subscribe to the channel and please also click the bell icon to receive more updates. Thank you once again.